Hi, thank you very much for the invitation to come speak today. I'll be speaking today about the eDecider project, a bit about our technology and challenges. I just wanted to acknowledge my colleagues and collaborators on the project. It's a multi-institutional collaboration with Indiana University, ImageCat, University of Missouri, Kansas City, the University of California, Davis, and a collaboration with the state of California, with the California Earthquake Clearinghouse and other partners. And I'd like to acknowledge our funding from the Applied Sciences program as well. So to sort of set this in context, I wanted to talk a little bit about the key requirements for the decision support project or products. So eDecider is a decision support platform that takes remote sensing and simulation products and delivers it to end users. Some of the considerations for delivering these products in context for disaster response takes into consideration the timeline for delivering these products. And it operates on sort of these timescales of immediate, intermediate, and longer term timescales, where for immediate response you have these crucial first minutes to hours following the event where you want to rapidly deliver these results for the initial response efforts. And then in the intermediate timeline, in the hours to days following the event, you have the continued response where you're refining your initial results and assessments. And then in the longer term, weeks to months following the event, you're identifying areas where repair to infrastructure needs need to be addressed. So with respect to earthquakes, which is where we've concentrated our initial efforts for our system, what we're trying to do is identify where the deformation is greatest and the likely damage has occurred so that decision makers can focus their response efforts. And some of the considerations that need to be addressed in creating your data products and delivering them to your end users are format and distribution, where you need to think about standards compliant and georeferenced data products, and standards compliant distribution services. And right now, one of the big considerations is how data is currently represented may not be easily understandable or digestible or interpretable by the end users. So as scientists, we really need to think about moving beyond our science products to actual decision support products or response products that are actionable by the end users. So just a little bit about eDecider. What we do is when there is an emergency event, our platform is triggered automatically to generate these products which are delivered to decision makers. And the workflow is basically we have these inputs which are remote sensing imagery, geodetic data, and a number of services that are based on our own eDecider services and the GeoGateway tools, which is a collaborative project with a sister project, so to speak. So then we create these OGC compliant data products, which include damage detection products, which are also have a validation process, deformation change detection products, and we have a damage and loss estimation service with critical infrastructure information and aftershock forecasts. These products are then delivered through our web portal and mobile interface, and also through a DHS developed middleware called Exchange Core, where connected agencies and applications can authoritatively and securely exchange information. And this we've been using in partnership with the California Earthquake Clearinghouse and other state partners with the state of California. And I'll show later in the presentation a successful activation with the state for the South Napa earthquake. So the project uses geophysical simulations and remote sensing observations to create these data products for emergency preparedness and response. And so we deliver these products to our end users, and we serve as a gateway to enable and deliver these decision support products to our decision makers and end users. And it's driven by this need for the accurate post-event information that enables the end users to deploy their resources in the early stages of the disaster. Okay. So a little bit about the service architecture of the system. So we use a service-oriented architecture. It's OGC compliant and open source. It uses Apache Aravata, open source framework for managing the computational jobs and workflows. It's on distributed computing architecture. It uses local clusters and supercomputers and can be distributed out to the cloud. And as I said, it uses a service-oriented architecture with geospatial web service APIs, and we're totally committed to OGC standards so that it's extensible and compliant with these data products so that the end users are able to easily use the data products. This is just a generalized workflow of our applications. So we have this workflow API that generates the various applications. We have this has this infrastructure KML generator that produces the maps with the infrastructure overlays. We have a mobile application API. We have the disloc feed, which creates the deformation maps. We have an aftershock forecast API. And then we also have an adapter that serves out all of this information to Exchange Core, which allows the secure data exchange with our agency partners. And all of the stuff can be displayed in XML, so in Google Maps, and we also can display this as GIS shapefiles, so it can go into ArcGIS Online, which a number of our partners also use. So one of the main services that we offer is damage and loss estimation database. So it takes information from the USGS Shake map files, and takes HAZUS damage functions and creates a damage and loss estimation based on the several HAZUS critical infrastructure layers. And it feeds it into a master database, and we're developing a service that allows user input to update in the event of an emergency so that users out in the field can take the initial damage loss estimation that is generated from the initial damage functions and verify out in the field whether the initial damage estimate is whether the damage has occurred or not, so they can do field validation based on the initial estimate. And there's also a protocol that we're developing for ingesting remote sensing change detection into this database for field validation as well. And this would be fed into Exchange Core and out to our users for the field validation part. So this just shows the crowdsourcing component of the validation for both the damage and loss estimation for the critical infrastructure and for the remote sensing. So we have 3 crowdsourcing modes where one is that the users can actively go out and take the information and create updates to the information, and then 2 other modes where they're basically pushed information where they can just go out and look at maps and field verified information that we've created based on damage maps that we've created. So for the HAZUS analysis, it takes the USGS ground motion data from the shake maps and does a direct physical damage assessment using the HAZUS methodology. And then you get a resultant map visualization. And I'll show a quick demonstration of that from the Napa earthquake in a slide coming up. So since it automatically downloads the required data, and it has a modular self-contained design, and it's fully integrated with the other components as a web service. So this is right now deployed, and you can create a damage and loss estimation based on a shake map, and create a site-by-site damage and loss estimation based on the shake map and the critical infrastructure layers. So here is an example based on the Napa earthquake. This was a successful activation of eDecider in conjunction with our partners at the California Earthquake Clearinghouse. We created map data products for rapid damage and loss estimation within 24 hours. And this information helped with allocation of resources. So on the left here, this is a strain magnitude map, which shows the areas of where the greatest deformation has occurred. And then we have here an airport facility with the resulting damage estimation from the infrastructure database. On the right here, we have the earthquake aftershock forecast map, again with the critical infrastructure overlay, and this is hospitals. And we have the resulting damage and loss estimation. And for this one, it shows that this particular hospital was predicted to have very low damage. And so this information can be pushed out to responders in the field, and they can go out and field validate this information. And this is information in a KML overlay, so they can download this to their tablet, go out into the field, and use this information to validate whether or not there was actual damage in the event. We're also working on a collaborative damage mapping protocol using optical imagery. This is integrating remote sensing and crowdsourcing. So with the remote sensing, it's using large-scale damage detection and GIS analytics. For the crowdsourcing, it's using distributed human sensing and ground truthing, and it's using dynamic integration through mobile cloud computing, and then further validating with the HAZUS database. So this is something that's in the works. Kind of bringing this all back into the context of working with our end users, we've been working in partnership with the California Earthquake Clearinghouse, CalOES, the California National Guard, FEMA, local governments, and other agencies. And so, again, what we do is we generate our products, and then we push them out through Exchange Core, which allows authoritative, secure data exchange. And then users typically query these products through incident control or incident command software. In the case of the clearinghouse, they have a web-based incident command software called Spot on Response, but there are others called NICS and others. And then those information are then passed on to decision makers at various levels, local, state, and federal. And we've been working with the clearinghouse since 2011. We've participated in 5 clearinghouse exercises, and as I just mentioned, we've had a successful activation for the South Napa earthquake. And as Susan mentioned in her presentation, we've been working with ARIA on these exercises and on the South Napa earthquake as well. So we've worked not only with the state but other NASA projects in delivering these data. So just to wrap up, some community actions for the future, or some things to consider. In coordination, just thinking about analysis efforts in bringing this information to the end users. thinking about how to distribute high and low level data products, and considering how to put the information architecture together in order to deliver these products. I know that Karen is thinking about this, especially with the ESIP projects that we're working on. Thinking on agreement on standards, data formats, OGC compliant data products, and distribution methodologies. We've been using Exchange Core, but there are web services, mobile services, and other collaborative environments, and all of these need to be compatible with the state of art in IT infrastructure. And data sharing is also a key point. And of course, the last thing that we should consider that's a very, very important point is, as scientists, how can we produce results that are immediately useful for disaster response? And with that, I don't know if we have time for questions, but I also wanted to point out some other AGU presentations that are associated with this project and might be of interest. And thank you very much.